Hi Intermediate, we're back with 9.1. I'm just going to finish the end part of it, which is the domain of a radical. I was talking to you earlier about if the index is even, like a 2 or a 4, like a square root or a fourth root. That means that what's underneath the radicand has to be positive. If it's an odd index, like a 3, a 5, a 7, what's underneath it can do positives or negatives, and they both can do 0. Excuse me. So the domain for an odd index is always all real numbers. So greater than or equal to 0 for an even index, all real numbers for an odd. Okay, so let's try some of these problems. Let me just put that over my head. Okay. So the top two are square roots. The bottom two are cube roots. So again, the rule for even roots is that what's underneath has to be 0 or higher. So you actually have to, that's actually how you solve it. So what you do is you say, what's underneath has to be 0 or higher. So for the first one, x plus 3 has to be greater than or equal to 0, because what's underneath has to be greater than or equal to 0. It has a restriction. So you actually solve that. You move the 3 to the other side, and you're going to get the domain for this is that x has to be greater than or equal to -3 for the number underneath to be 0 or higher. So that is actually the domain. If you want to write it in the fancy notation, it would look like this, in that interval notation, which is real nice. Okay, same thing here. This is an even index. So what's underneath has to be greater than or equal to 0. If it's even, what's underneath has to be greater than or equal to 0, because you cannot have a negative number under a square root or any kind of even root. So that means that, maybe let me solve it over here this time. That means that x minus 7 has to be greater than or equal to 0. Then I move the 7 to the other side. So x has to be greater than or equal to 7. So that's the domain of this one. X has to be greater than or equal to 7. And in fancy notation, in interval notation, it looks like that. Okay, they were both even indexes, so that's why they have the restriction of having to be 0 or higher under the radical. Now, anytime it's an odd index, you don't have the restriction. You could put anything you want under there, because it could be positive, it can be negative, it can be 0. There's no restriction. So since this is an odd root, it means that it's all real numbers. That means that x can be anything we want. There's no wrong number. There's nothing that will not work. Everything works. Okay? If you want to do the fancy notation on that, that's negative infinity to infinity. Okay, same thing on the last one. That's an odd index. So again, if it's an odd index, it can do anything. It can do positives, negatives, and 0. So it's fine. So again, this one, since it's an odd index, is all real numbers. Or you could do the fancy notation for this. Okay, gang, so I'll now put up some homework for this section. And I hope these videos have helped you and that you can work through these problems. I'll catch you soon. Bye.